Good evening. We have a comet. Not a brilliant one, but a comet nevertheless. This is Bradfield's comet, so called because it was discovered by the Australian amateur Bill Bradfield. And this is his 13th comet discovery, which I think you'll agree is a pretty good record. It's a morning object now in the constellation of Ophiuchus, the serpent bearer, and as the days go by, it will track along in the general direction of Aquila with the bright star Altair. You can just about see it with the naked eye if you know what it is, and binoculars show it very clearly as a kind of a rather dim fuzz. It's not going to get much brighter, but it is there, and it certainly is well worthwhile looking at. But now, on to my main topic this evening. I've been having a great many letters from people who say, I want to buy a telescope for Christmas, either for myself or for my son or daughter. What should I get? Now, do let me stress, please, that what I'm going to say now represents my own opinions, and others may not agree, but I can only speak as I find, and I have been looking through telescopes for a good many years. And I'd like to begin by showing you my own first telescope. Here it is. It's a 3-inch refractor, and I had it when I was a boy of 11, and that goes back to 1934. It wasn't new then. I think it must have been built around about 1910. And I call it a 3-inch refractor because it collects its light with a lens or object glass 3 inches across. But before going any further, may I please get rid of one of my own particular hobby horses. Whatever you do, don't look straight at the sun through any telescope or any pair of binoculars. I know that I've given this warning many times, but it really is important, and I don't apologize for repeating it. So never look at the sun, even when you're using a dark lens to be fitted over the eyepiece. It simply isn't safe. What you'll do is to focus the sun's light and heat onto your eye, and in a fraction of a second, you will damage your eyesight and possibly blind yourself permanently. And that applies even when the sun is low down in the sky and looks deceptively mild and harmless. It's anything but that. So if you want to observe the sun with the telescope, there is one good way to do it, by the method of projection. And that's why I've got that kind of screen fixed up there on the end of the telescope, merely made of cardboard. So this is what you do. I'm afraid we can't bring the sun into the studio. The next best thing is to create an artificial sun, and we've done that in the shape of an illuminated triangle over on the far side of the studio. So this is the procedure. First of all, align your telescope with the sun without looking through it and without putting your eye anywhere near the eyepiece. And then hold up your screen behind the eyepiece, and there you will see the image of the sun projected, just as the image of that triangle is now projected onto the card. And in that way, you will see any sunspots that may be around, and you'll see them very well indeed. And in my view, that's the only safe way to do it. Anything else is quite harmless. By looking straight at the full moon through a telescope, you may dazzle yourself, but you can't hurt yourself because the moon sends us virtually no heat. Now, this telescope does in fact give you pretty good views of all kinds of things. What about the planet Jupiter, which is that very brilliant thing you can see now in the eastern sky after sunset, shining far more brightly than any star? The other night, I had a view of Jupiter with this telescope, and there's the drawing that I made then. And you can see there the dark belts, and the bright zones, and even one of the 4 bright moons. I'm afraid you can't see the great red spot on Jupiter, that very famous feature, because at the moment it really isn't on view. It's very obscure. It does come and go. It will certainly come back, but at the moment it's not there, at least not very obviously. What else? Well, what about the moon? You can see the mountains, the craters, the valleys, splendid views with this telescope. In fact, the first astronomical paper I ever published when I was in my teens was done by observations made with this telescope. And this is the kind of thing you're going to see on the moon. Note, please, that the image is upside down or inverted. And that is because an astronomical telescope does turn everything upside down. In fact, an ordinary telescope for daytime use would also do so, but for the fact that we introduce an extra system of lenses to turn the image the right way up again. But every time you pass a bit of light through a chunk of glass, you lose a certain amount of light. When you're looking at birds or ships out to sea, that doesn't matter a bit. It matters very much in astronomy, where you want to collect every bit of light you can. So the correcting lenses are simply left out, and we see upside-down images. Now, how does a refractor work? The main light collector is the object glass, in this case a 3-inch. The light goes through the object glass, passes down the tube, is brought to focus, and the resulting image is magnified by a second lens or eyepiece. And note, please, that the light collection is done by the object glass, and that's what really matters, and all the magnification is done with the eyepiece. And by varying your eyepieces, you can vary the magnification. And every telescope comes equipped with several eyepieces of various powers. But there's one golden rule here, and one rule that's sometimes neglected. Usefully, you can only employ a magnification of about 50 per inch of aperture. And by 50, I mean you're making the image 50 times larger than it would be if you saw it with the naked eye alone. 50 per inch of aperture. Here I've got a 3-inch object glass. Therefore, I can magnify by 3 times 50, or 150. And 150 is really the maximum useful power to be employed on this telescope. Now, of course, in theory, you can use much larger powers. But remember, you've only got the same amount of light, the light collected by that object glass, and when you spread it out into a larger image, the image is going to be fainter and more diffuse. And I made a series of drawings the other night to show just what's meant, all made with this telescope. Again, of Jupiter. Here first is Jupiter, magnification 50. You see the belts, you can see the 4 bright moons, Io, Europa, Ganymede, and Callisto. Next, I put on a power of 150, which is about the maximum you can really use. This time, the field of view is smaller, so 2 of the 4 moons are out of the field. You can see the belts very nicely. And then I put on a magnification of 400, and this is what I got. The image is the right size, all right, but you can't see anything. It's too diffuse, and it's too faint. So you cannot use a magnification of 400 with a 3-inch lens. And the golden rule, 50 per inch of aperture, is, I think, very important indeed. And even that can't always be used. And if you're observing and you find your image is blurred, then change at once to a lower magnification. And there's another point here, too. You sometimes see telescopes advertised which will magnify so many times without anything being said about the aperture. And the aperture of the object glass is what matters. So if you are thinking of buying one of those, check to see what the aperture of the object glass is. And if the advert says you're magnifying more than 50 times per inch, then my advice is to avoid it. Now, then we come to the all-important problem of cost. As I say, I bought this telescope way back in 1934. I saved up my Christmas presents, birthday presents, pocket money, everything else, and finally I accumulated the sum of £7 10 shillings. And that was quite a large sum in those days. And with that, I bought this telescope. But very sadly, we've got to say that times have changed. And if now you're going to buy a 3-inch refractor like this, on this kind of mounting, you're going to pay at least £350 and probably rather more. Now, you can, of course, buy smaller telescopes, and there are plenty of 1, 1.5, 2, and 2.5-inch refractors on sale. But frankly, I wouldn't recommend them. Remember, only a magnification of 50 per inch of aperture, and when you have these very small telescopes, they just don't collect enough light to be useful. So my advice is, don't buy any refractor with a lens less than 3 inches across. Of course, larger refractors are excellent. I've got a very fine 5-inch set up in my observatory in Chelsea on a permanent mounting, and there it is, and that really is a beauty. And the other night, I made a drawing of Jupiter with that, and that's what I saw. I went out a detail upon Jupiter's disk. And compare that with the view you get through a 3-inch refractor, and you can see how superior the 5-inch is. But of course, a 5-inch refractor does cost a great deal of money. So, what next? Let's leave refractors for a moment, and now change and have a look at the reflecting telescope the second time. And I'm going to talk about Newtonian reflectors, because these are the most common, and so called because the principle of this kind was first worked out by Sir Isaac Newton. And here, in fact, is a 6-inch Newtonian reflector. Note this small telescope fixed onto it. That's a very small refractor, simply used as a sighter, because trying to turn the main telescope onto a particular object in the sky is quite a problem. So you first get it in the wide field finder, and then, if everything's set up correctly, it'll also be in the field of the main telescope. So here we have a 6-inch reflector. This time, there is no object glass. The light from whatever you're observing comes straight down the tube and strikes a mirror at the bottom. That mirror is specially curved and sends the light back up the tube onto a second mirror, which is flat, and that diverts the light into the side of the tube, where an image is formed and magnified by an eyepiece, just as before. And the same rule applies, a magnification of 50 per inch of aperture. So with this 6-inch reflector, I could use 650s or a magnification of 300. Note also there's a difference here in the kind of mounting. The first one I showed you was a simple one. Here we have what's called an equatorial mounting. Now, as the Earth goes round, things appear to rise, cross the sky, and set. And that means they go either up or down, and also east to west. Up or down in altitude, east to west in azimuth. Now, here we have a telescope mounted upon an axis which points toward the celestial pole. And then as you move your telescope in azimuth, that is east to west, the up or down motion looks after itself. So you've only got one movement to bother about, and of course that makes things a great deal easier. And if you like, you can then fit on some kind of mechanical drive, and that will turn the telescope round just to compensate for the Earth's rotation, and once you've got your object in the field of view, it will stay there. That is the equatorial. Here we have a refractor, which is on an alt-azimuth mounting. It will move freely either in altitude or in azimuth. That means you've got two movements to bother about, and that does make things rather more awkward, although here you do have slow motions which make things rather easier. So the prices of these two telescopes are roughly the same, between £400 and £500. So if you're going to spend that sum of money, what are you going to get? Are you going to get a 6-inch reflector or a 3-inch refractor? Inch for inch, the refractor is the more efficient of the two, or I would say that the 6-inch reflector will just about beat that 3-inch refractor. And it really depends upon what you want to do. If you want to go in for projecting the sun, then a refractor has it every time. I'm very refractor-minded. They give lovely, crisp images. And of course, I am essentially an observer of the moon and planets, so I like refractors. But if you're interested more in star clusters, nebulae, and what we call deep sky work, I think probably the reflector is the better. But it really is just what you want to do. But in either case, you have got to spend a pretty considerable sum of money. And if you don't want to do that, what are the ways out? And one way out, of course, is to make your own telescope. Now, you can, in fact, do that. You can grind not a lens. I think lens making is a job for the real expert with a well-equipped laboratory. But you can grind your own mirror. It's not actually very difficult, even for someone who's as clumsy with their hands as I am, but it does take a long time, and if you decide to try it, then be prepared for a good many disappointments. And if you don't want to do that, then the answer is to buy the optics and then mount them. And that's what's been done by my old friend Reg Spry, who lives quite near me in Chelsea, and wanted a powerful reflector, and didn't want to drive all the optics himself. So he bought a 6-inch mirror, and the flat, and the eyepiece, made a finder out of an old binocular mounting, and equipped himself with a very fine 6-inch reflector. Now, the actual optics cost him £20. That was way back around 1970, 1971, and of course you can more than double that now, but even so, it's fairly reasonable. The rest of it actually cost him, I think, 25 shillings. You've got a square tube here, and why shouldn't you have a square tube? The only function of a tube is to hold the optics in the correct positions. This one was made out of shells from an old larder. Part of the mounting is made from a dismantled car mounting, and so on. And in this way, Reg Spry did produce a very fine telescope. It's an alt-azimuth, of course, and it works excellently, and I've used it many times. I remember the other night looking at the Orion Nebula through it, that lovely cloud of gas and dust below the 3 stars of the Hunter's Belt. With a low power, it will look like that. But with this telescope, you can see real detail there. The bright and the dark rifts and the stars which make it shine. And believe me, this is a really good and really effective telescope. And if you don't want to grind a mirror, then this is the way to go about it. And while I admit that Reg Spry is particularly good at this kind of thing, there are people who can emulate him, and I think this is within the bounds of any reasonably competent amateur. So where do we go from here? If you're going to buy a telescope, then you've got to spend a large sum of money. If you're going to make one, well, fair enough. On the other hand, you may decide that you want to get one second-hand. And this is not really quite so easy as you might imagine. There are many advertisements around, but a good telescope is a good telescope, but a bad telescope may look like a good telescope until you go into first courses. So my advice is, if you're going to buy a telescope second-hand, then do go and take good advice, either from a local astronomical society or from the British Astronomical Association. It's better to be satisfied than sorry. Of course, there are other kinds of telescopes, and I've got one here. This is a compound optical system. It's very powerful. It's got an 8-inch primary mirror. It's clock-driven. It's equatorial. It'll give magnificent results, and I thoroughly recommend it. There is only one problem about it. The cost of this is something like £1,500. So I'm afraid it's going to be beyond the range of most people. Now, up to now, I've been talking about telescopes I would recommend. Now let's come on to telescopes of the kind that I personally would not recommend. Dudley Fuller is a telescope expert, and he's brought along just one of these telescopes. It is, in fact, a 2-inch refractor, and just look at it. First of all, the mounting is unsteady. It wobbles around, and once you have an unsteady telescope mounting, really the telescope is not very much use. But there are other problems too. a 2-inch object glass won't collect enough light to be really useful, even if it's of good quality. This particular one is not of good quality, and there are even worse aspects, are there not, Dudley?
Well, that's right, Patrick. Frankly, I've always thought this particular telescope is an excellent telescope for demonstrating how awfully bad they really can be. I think you've already mentioned the shake in it, but I think what is really the problem with it is its lens. Now, the lens on this particular one is a single-element lens, which will give you an awful amount of colour down at the eyepiece end. To correct the colour, one needs a double lens called an achromat. And it is important when buying a small telescope or even a large refractor, you always make sure that you're asking for an achromatic telescope. This is really vital. This one, well, is horrible. And down here, to make matters even worse, is a little hole about 1 inch. So in point of fact, the person is not buying a 2-inch telescope, or as sometimes I've seen these, a 3-inch telescope. They're buying a 1-inch telescope. And quite frankly, it's something that we just couldn't possibly recommend. They'd see virtually nothing. Really would be terrible.
Well, that's not the only point, of course. As I've said, a 2-inch really is too small. And therefore, if you're going to get a telescope, you've either got to get one second-hand and be lucky, or else you've got to spend a large sum of money. But what is the other alternative? And there is one pretty good alternative, and that is go and buy yourself a good pair of binoculars. Now, I've got a collection of binoculars here. Here, for example, is a little 8 by 30 pair, costing about £25, magnification 8, each object glass 30 millimeters across. And really, a pair of binoculars is merely 2 small refractors joined together. And the situation is quite different from an ordinary small telescope, because this time you're using both eyes and a low fixed magnification of the kind you couldn't use on a telescope. So I think the minimum useful aperture for binoculars is not less than 30 millimeters and not more than about times 12 magnification. For a refractor, a 3-inch lens. And for a Newtonian reflector, a 6-inch mirror. Now, you may say, why not higher magnification binoculars? Well, of course, you can use them, but there are certain problems. These are easy to hold steady. I've got a pair of 7 by 50s I'm very fond of, and always loop them round your neck first, I may say, otherwise they'll get dropped. And those also are fairly easy to hold steady. But if you don't want to do that, it's quite easy to buy an attachment, and it costs £1 or £2, and you fit those onto the binoculars, and you can then simply put them onto an ordinary camera tripod and aim them in just the same way as you would aim a camera when you're taking a picture. That's all right. And when you come to higher magnifications with a smaller field, things are really essential in that way. For example, these 11 by 80s, well, they're lovely binoculars, but holding them up is quite a problem if they're going to hold them steady. And with those 20 by 70s, it's really rather impossible. So you do need a mounting. You can, of course, have something of the same kind. Here's one, another on a tripod. And there is one other example, too, and that is a neck mount. And Dudley Fuller's got one of those to demonstrate here.
Yes, Patrick. This is a brand new all-British invention. It's even made in England for a change, for holding your binoculars. It makes everything very, very stable. You're forming a triangle with your arms, straight up to your eyes, and everything's as steady as a rock. They really are good.
Cost?
Around about £35.
And for £35 for a good pair of binoculars, for less than £100, you can get really good equipment. And that, in my view, is far better than a very small telescope. And if you'd like more information, we have got a telescope fact sheet now available. And if you want that, simply send the stamped addressed envelope to A Telescope for Christmas, Fact Sheet, The Sky at Night, BBC TV, London, W12 8QT, and you'll look that up on CFAX, page 186. But if you do decide to get a telescope for Christmas, please take care. You may get a good telescope cheaply if you find one second-hand, but do take a skilled advice first. It's far better to get a good telescope now that will last you for many years, rather than buy a very small one or a telescope which looks good and isn't. So beware, but I wish you all success. Good night.
Second chance to see That Sky at Night on Saturday afternoon at 4:20 on BBC Two.